So this video is going to talk about composite functions and being able to identify the components of these functions. All right. So when you talk about a composition of functions, what you're thinking about is that you have one function sort of composed inside of another. And so the notation that I think most of you would have seen in high school is this right here, f of g of x. But this is going to be our more standard form for writing a composite function. And again, the way that reads is f of g of x. Okay, so g of x is inside of f. Okay, so what we're going to have to be able to do for the next part of the unit, which is taking derivatives using what's called chain rule, what we're going to be able to do here is identify which function is our outer function. We're going to call it f, and which function is the inner function. We're going to go ahead and name him g. Okay. So we have to be able to look at any composite function and be able to figure out which is which so that we can move forward with taking derivatives of these types of functions. So we're actually going to start really simple here. We're going to look at h of x as an example, and we're going to just identify which is f and which is g. So what you want to do is look for something that's a little bit complicated, more complicated than just a single variable like x or y. All right. And you're looking for it to be inside of something else, some other operation. Okay, so what I see is that I have a linear function, 3x plus 1, inside of these parentheses, and it's being raised to the second power. So the 3x plus 1 is what's inside, so that will be my g. And then what I'm doing to it, right, that function type is my f. So I'm squaring the 3x plus 1. So my f is going to be just x squared. Okay, now the reason why it's x squared is because remember what we're trying to do here is suggest that if I replace x in f of x with the whole g of x, I should get what I have here to start. So let me show you that what that looks like. So f of g of x means I am going to replace x in f of x with 3x plus 1 because that's what g of x is defined to be. All right, well, the x in f of x is here, and I am squaring it. And is that in fact what I have? Yes, it is. So that's my check. So I have identified f and g properly. And then I've just checked to make sure that what I've suggested there makes sense. Okay. All right, let's go to the next one. So we have m of x equals the square root of 2x squared minus 1. So when you hear that word of, that should kind of guide you towards what you're looking for, right? Here I have f of g of x. And here I'm taking the square root of 2x squared minus 1. So the 2x squared minus 1 is inside of a square root. So that 2x squared minus 1 is what I want my g of x to be. That's the function inside of another. And what am I doing to that? Well, I'm taking the square root of it. So f of x is the square root of x. All right, let's go ahead and check that and make sure that that makes sense. So f of g of x, again, that means instead of x in f of x, I'm going to put in g of x, which is 2x squared minus 1. So I want f of 2x squared minus 1. So instead of x, I'm putting in 2x squared minus 1. So this gives me the square root of 2x squared minus 1. So is that what I have? Yes, that's what we started with. So I've selected f and g properly. Okay. All right, the next one. Here I have the natural log of the sine of y. So you can see that the sine of y is inside of the logarithmic function ln. Okay. So our inside function, we're not going to be able to call this g of x now. It's going to be g of y. We're looking at functions of y, is going to be the sine of y. What am I doing to that? I'm taking the natural log of it. So f of, again, we're going to write y here, is going to be the natural log of y. All right, and so again, let's go ahead and check to make sure that that is accurate. So we have f of g of y, right? And that means we want f of the sine of y, because that's what g of y is. So that means everywhere I have a y in f of y, I'm going to replace it with the sine of y. So now we have the natural log of, instead of y, sine of y. And that's exactly what we have here. Okay, so again, everything's been selected properly. Good to go. All right, come on down. We got 3 more and then we are done with this video. This one's a little tricky. All right, we have e raised to the square root of t. And so you don't really hear the word of except for the square root of t, but that's not super complicated. But what you should notice is that you do have an exponential function, and then in its exponent, hear the word in its exponent, you have the square root of t. So the square root of t is inside of the exponential function, okay? Because instead of just raising e to the t, you're raising e to something more complicated than just t. So I'm going to go ahead and claim that my first function, my inside function g of t, is the square root of t. And don't forget, I'm looking at t's now, right? Not x's, not y's. What am I doing to the square root of t? I'm raising it by base e. So my f of t is e to the t power. All right, so let's see here. F of g of t, that would be the same thing as f of the square root of t, right? Because g of t is the square root of t. So everywhere I have a t in f of t, I need to replace it with the square root of t. So that gives me e to the square root of t, which is exactly what we have. So we've identified f and g properly again. Right. This one's even trickier because it's not obvious at all where our composition is. We have 1 divided by t squared minus t. Well, if this was just 1 over t, that would be a super easy function to look at because we know what the graph of that is. All right. So what I'm thinking about here is that my denominator has something more complicated in it than just t. So I'm going to go ahead and let g of t be t squared minus t. What am I doing to it? I'm putting it into the denominator. So I'm putting it into 1 over t. All right, and so f of g of t, again, that would be f of t squared minus t. Everywhere I have a t in f of t, I'm going to replace it with the quantity t squared minus t. That gives me 1 over t squared minus t. And yep, that's correct. So sometimes they're super obvious and other times not so much. All right, one more. Here we have the cosine of e to the y. So the e to the y, the exponential function base e, is inside of the cosine. So my g of y, again, because now I'm looking at a function of y, is e to the y. What am I doing to it? I am taking the cosine of it. So f of y is the cosine of y. Let's go ahead and check that. So f of g of y, that's going to be f of e to the y, because that's what g of y is. And so that will give us the cosine of, instead of y, e to the y, which is exactly what we're looking for. And so now we've used 6 different examples to learn how to identify the inside function and the outside function in a composite function. And it's really important that you're able to identify these, because without being able to do so, you won't be able to take the derivatives of functions of this type using chain rule.